Hello, my name is Charlesetta Walker. My presentation today is on crime analysis for predictive policing, Baltimore City, Maryland. This presentation will review the following highlights: data analysis project description, dataset description, the data at a high-level review, describe data preparation requirements, data analysis strategy, lessons learned, and next steps. The purpose of this project is to reduce crime rates in Baltimore City, Maryland. To do this, we hope to provide the Baltimore Police Department with effective methods in combating victim-based crime incidents by utilizing data analysis methods. We will take historical crime stat data, which is obtained from the police log database, and determine high crime frequencies, their primary locations, and the time frames at which they are most likely to occur in the future. We will use a multi-step analytical approach involving descriptive analysis, clustering, and predictive modeling. These methods will provide tools for better policing, enabling strategic deployment of limited resources for faster response times and increased perpetrator arrest, all aiming to deter future criminal activities. The overall concept is predictive policing. A definition of predictive policing from the National Institute of Justice states, predictive policing tries to harness the power of information, geospatial technologies, and evidence-based intervention models to reduce crime and improve public safety. This two-pronged approach, applying advanced analytics to various data sets in conjunction with the intervention models, can move law enforcement from reacting to crimes into the realm of predicting what and where something is likely to happen and deploying resources accordingly. In order to better understand this project and its goals, it's necessary to have some basic understanding of the city and its police department. The Baltimore Police Department has approximately 2,779 officers, which are assigned to 9 district police stations. The map shows a boundary of each of the districts, and the points on the map represent the locations of each district police station. The city of Baltimore is the 26th largest U.S. city in population, but it ranks number 6 for violent crimes and number 2 for homicides. It has approximately 624,000 citizens who live in 320 neighborhoods. The data set used in this project was obtained from the Open Baltimore website. This database contains incident information that is updated and maintained by the Baltimore Police Department. The content of the database includes information such as the date, time, crime type, crime code, crime location, weapon used, location by street, location by geographical coordinates, the district, the post, and the name of the neighborhood. Now, victim-based crimes are crimes that have specific identifiable victims. This project does not include all crime types, such as illegal firearm possession, drug possession, bank fraud, and cyber crimes. Here we have a high-level review of the data used in this analysis. The data set contains 276,053 rows of individual crime record observations within a structured table. There are 12 variables, and the data covers a time period starting January 1st, 2011 through September the 10th, 2016. There are several relationships between variables. For instance, the crime code is a subset of the crime description. The description value may specify a larceny, but the crime code will specify if it was a larceny with a weapon or done by hand. Some of the crime code values are related to the weapons column. The post is a further division of the 9 districts, and the neighborhood is a further division of the post, and the physical address location is a further division of each of the neighborhood names. On the left-hand side, the table shows a statistical breakdown of each of the variables. Includes the name, the detailed description, the class level counts, the most frequently used value for that variable, and the percentage of the total of the values for each of those variable names. Before the dataset can be used for analysis, it's important to perform several preparation steps. One of the most important preparation steps involves finding out the missing values for each of the variables. The one that stood out the most was the weapons variable, which had a missing percentage of 66%. There were some anomalies in the coding. For instance, the crime code definitions, some of the definitions or the values used were obscure, so I need to do a little bit further research on those to make corrections. Also, the neighborhood has an official count of 320 names, and the dataset contains 279 distinct values. Also, the district has an official count of 9, but there are 10 of the values showing. And also, the inside-outside of a variable should be a binary class with I or O, and instead it is showing distinct values totaling 5 levels. So basically the list of data preparation steps start with using SAS Enterprise Miner and Microsoft Excel to assess the summary statistics, finding the missing values, anomalies, errors, frequency count, and other things. Then locate the possible coding errors and apply the logical corrections. Then we would determine the missing values and apply the most viable solutions depending on the analytical method used. For the weapons options, I might want to impute those values to unknown, or as an alternative, I can use some of the crime code definitions for guidance on whether there was a weapon used or not. The next step would be to add variables that I feel would be necessary to improve the analysis, such as having a listing of the day of the week of the incident, Monday, Tuesday, Wednesday, etc., the shift, morning, noon, or night, and we're going to round down the timestamp. Instead of being down to the second, we're going to round that to the hour. And then there are a couple of variables that should be renamed for clarity. And then the last step is to drop unnecessary variables. And the one in this case would be the total incidence, in which all of the values are coded as 1, so that we had no obvious value to the analysis. The general strategy of this analysis is to first uncover associative patterns between the attributes and then predict crime. Several approaches will be used. The first important method is descriptive analysis, and this is to give an overall picture of crime incidents throughout sections of the city, using geospatial data to uncover hotspots, and historical data would be used to detect changes compared to other periods, finding trends and sudden spikes. The next method is k-means clustering for the modeling portion of the analysis, and this will be used to uncover possible close associations between incident characteristics. This is useful for processing large cases and with the flexibility to adjust the number of clusters, which is the k value. The clearer groupings can be created using filtering methods, and the results can be used to determine the best inputs for the next step, which is predictive modeling. For the predictive modeling stage, the first method used is the decision trees. Now this is useful for both predictive and classification tasks. The method consists of a set of rules to divide the data into smaller groupings with respect to a target variable, which most likely would be the type of crime. This method of modeling is simple to understand and interpret. The next method would involve using the neural networks method. It has a generally higher accuracy than decision trees, but is much more complex. The weighting technique used by neural networks, this algorithm can produce a probability score for the target class used, and filtering can be used of the independent variables, which would allow focus on specific problematic city sections. The software tools for this analysis, 3 primary tools will be useful, and the first one is Tableau, to offer a visualization for descriptive analysis. Then there are SAS Enterprise Miner, which offers predictive tools, several predictive tools, and I will use the decision trees and neural network options. and finally, the R programming in R Studio, and this will be a convenient method to use for k-means clustering analysis. There are two major expected outcomes from this project. The first is the realignment of police resources to better manage the crime hotspots. That involves reducing patrols during times of low criminal activity and increasing the patrols where needed, identifying upward crime trends and sudden spikes, targeting investigations in order to find specific causes and perpetrators of crime, and to tailor police training for more or better effective handling of specific types of crimes in certain hotspots. The next major outcome is crime deterrence. Strategic patrolling will be applied to decrease response times and increase the chance of suspect capture. And this will further curb crime incidents, such as store robbery sprees and home break-ins, multiple home break-ins. It should also increase arrest, which would prevent repeat criminal incidents, and also enhance proactive community safety efforts for businesses and citizens. In preparing for this project, there were several lessons learned in the process. First of all, the in-depth crime analysis can be a very complicated process, as there are a wide range of other approaches that are possible, starting with arrest-based data or using perpetrator data, 911 call logs, and socioeconomic data. And the combination of too many of these types of data sets can create an unwieldy project scope. So it was important for me to just narrow down the focus of this project on the victim-based data. Also, in my research, I found some conflicting recommendations for the best approaches to crime data analysis when it comes to predicting the crimes themselves. It is a growing subject and an important one between several police departments throughout the country and throughout the world. And the subject of policing itself is a very controversial subject due to the various recent incidents in Baltimore, Maryland. So I need to be sensitive and aware of all the issues surrounding policing too in my analysis. And it's also difficult to obtain accurate code definitions. So there is some conflicting, a little bit of conflicting information on some of the definitions of the crime types and the crime code. So I'm going to continue to look into that. The purpose of this presentation was to give an overview and an understanding of the first phase of the project. The next steps involved the exploration and descriptive analysis. Then we will move into the actual analytical modeling using the k-means clustering, decision trees, and neural networks, which will be an iterative process. Next, once we have the accuracy test completed and compare results, I will explain the findings, and then from those findings, formulate a list of suggestions for the crime reduction solutions and give further recommendations. Also, as throughout the entire project process, I will continue to read up on the most recent information for predictive policing, finding out the benefits and the issues involved, examine crime stat analysis techniques and the best interpretations of those results, and also do further research on practical applications for the findings of this project. This now concludes my presentation. If you have any questions or would like to suggest improvements for the project, please contact me, Charlesetta Walker, using the contact information shown on your screen. Thank you.